at vector addition from another standpoint. We'll look at partial sums and multiple sums and differences. So whenever from yesterday, we always add vectors head to tail. So if you were to add A plus B, you would add those head to tail. It's like you started here and then you continued off of A to B. Is that A plus B? That is not A plus B. A plus B is an actual vector that goes from the tail of the first to the head of the last. And so tail of first to the head of the last is an actual vector, which we call R. That is the answer, is a vector. You must have an arrow showing where it's going from, and the tail is going to start at the beginning. You need to label R. So if you don't want to lose any points on a quiz, make sure you have the arrow and make sure you have that. Now this is what we call the triangle method. And the reason it's the triangle method is because you put those A plus B, you get a nice little triangle. Now what if I added B plus A? What happens there? We had A plus B. Now I'm going to do B plus A. Where do you end up? Where do you end up? Same place. Still they're equal. This is something that you need to know. They call it parallelogram method. It's just to show that vectors are commutative. You've heard that word before, haven't you? Commutative. And so that's all the properties you can add. That means it has closure. A plus B is B plus A. Think of these as little vectors. Associative means that if you took A plus B plus C, you grouped these two and then added C, or you grouped the second two and added A, you'd still get the same thing. Anything plus 0 is equal to anything. And then A plus the opposite of A gets you back to 0. And you can certainly see that if I were to clone this and flip it like that. A plus opposite of A is going to get me back to the beginning, which is 0. All right, so what can we do with vectors? Well, this opposite of A thing is helpful because if we want to go A minus B, we can add B going in the opposite direction. So if this is A, and this is B, oh, didn't clone it, come on, there you go. We're going to go the opposite of B, so it's in the opposite direction, and now you have minus B. A minus B, if this is not it, you need to drop from the tail of the first to the head of the last, have the arrow, have the little R. Now, that is A minus B. We can look at multiples, like if K is greater than 0, we can look at 2B. 2B is just going to be this one plus this one together, making 2B. Does that make sense? So this whole thing now is 2B. Or not 2B. No, that would be the opposite direction. And then you can do fractions of it. You can have equal to 0, it would be the 0 vector. So let's see what 2A minus 1/2 B would look like. So I'm going to take all of these, and I'm going to take 2A. So here's A. 2A. It's going to be 2 of them. And then half of B, I'm going to clone this one. Whoop. I guess I'm going to disappear. Clone it. And we're going to subtract, so it's going to go the opposite direction. And then we're also going to take half of it. So it's going to be about, let's see if I can do this. Get it a little bit bigger, so it's about half. Whoop. You know what I mean. You know what I mean. It's about half, a little less. Ooh, that's good. That's the opposite direction. Where is the opposite of half b? Minus half of b. Okay? So then when I draw that resultant, that is not 2a minus half b. This is r. You try this one, 1/3 b minus 3a. Give that one a try. So when you sketch this one out, what you'll have is 1/3 b. It's about like this, 1/3 b. And then we're going to subtract 3a. So a goes up, minus 3a goes down. 1, 2, 3. There's your minus 3a. So did you get something that looked like that? Does that look about right? Alright, so you go to this next one. Here's 4 for you to do from a real picture. See if you can find a minus b, b minus 2a, and so on. Good luck. Give you a couple minutes. Different directions, like this first one. You copy a, then you copy b, but you go in the opposite direction. So minus b is actually going to be up. So your resultant, tail of the first to head of the last, is going to be up. How many had something upward like that? Anybody confused on those? So then the next one, we're going to do b, and then we'll do minus 2a. So here's b. Minus 2a is going to be 1, 2 of those. And so if we go from the tail of the first to the head of the last, that resultant's going to be straight down. So the first one was straight up, pretty much. This one's straight down. Let's do 2b minus 3a. So 2b is going to be 1, 2b minus 3a. Well, that's going to be, a is up this way, so it's going to be 1, 2, and 3 will be minus 3a. So when I draw that resultant from the tail of the first to the head of the last, that one's going to be pretty big going down. Show me with your iPads what you had for C. Okay, going down, 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 all right, good. And then the last one is just half b plus half of 2 is 1a. So for this one, this is a quicker one because it doesn't go as far. You're going to go half of b, and then you're going to go plus a. So that resultant is tail of the first should be up and to the right. So there you go. There's adding, subtracting, multiples of vectors. Don't you dislike having to draw it? Wouldn't it be better if you had actual numbers? That's what we're doing next, tomorrow. Before we do, I'm going to show you how you can pull a car out of a ditch. Now, a lot of you don't believe this, but you have the strength to pull pretty much even a truck out of the ditch. So, Ben, I'm going to say you have your car, this instead of a tree, you have a car, stuck in the mud. Okay? And you want to get that out of there. So what you're going to do is you're going to tie a rope to the little attaching spot into there and to the tree, and then in the middle, you're going to apply a force. Now there's going to be a little winch here that you're going to be able to hook onto both ropes, and you're going to be able to winch that. But for right now, you're going to, let's say, and I know Ben can apply more than this, let's say it applies 10 pounds of force. Is that going to pull a car out? You wouldn't think so. But let's say there's a lot of slack in this line, and it's a 120-degree angle of slack. He's pushing down this goes down 120 degrees. What will the forces be here and here on that rope? We're just using math here, okay? So I'm going to take 10 pounds, and I'm going to apply a force of X, and apply a force X. Now, this is 120. If I extend this out, this is 120, right? 120. If I extend this out, what would this angle inside here be? 60. Now, these two are the same magnitude, so these two have to be the same. Well, we're going to share 120, making all of these 60. So if you were to look at this, applying 10 pounds, you're only applying 10 pounds to the tree and to the car. It's not going to get unstuck. So we're going to have to tighten this up. So you're going to ratchet this a little bit, and we're going to ratchet it only because of the angle. We're going to ratchet this so the angle is 170 degrees, almost straight across, almost 180. Now this has a force of X, this has a force of X, but you're still applying 10 pounds. So if you look at it, you're going to have a force of 10 pounds, and then it's going to be X, and then it's going to be X. All right? And we want to see what that force is. Well, if you extended this out, this is 170 degrees. What will this little angle here be? 10. And then we're going to share 170 between these two. This will be 85 and 85. Well, we can use law of cosines here, or sines. X over the sine of 85 will be equal to 10 over the sine of 10 degrees. So X is going to be 10 times the sine of 85 all over the sine of 10. Would you take out your calculators? What is that equal to? 7. This is going to be 57 point how many? 4 pounds. So just by tightening that up, my 10 pounds turns into almost 6 times as much. Let's tighten it up some more. So this time we're going to tighten it up, and it's going to be almost 180. Let's make it 179 degrees, still applying that force of 10 pounds. Okay, so let's do the addition here. 10 pounds, X, X, but this time this angle is 179 degrees. What will this angle here be? 1 degree, and we're going to share 179, 89.5 degrees for this. Now use the law of sines, and you're going to get X over the sine of 89.5 is equal to 10 over the sine of 1 degree. So X is going to be 10 times the sine of 89.5 over the sine of 1 degree. And I need your help. What will that calculation be? Let's 572 pounds. Applying a force of 10, you get 572. Do you think Taylor could apply a force of 20 pounds? Easy. And that would be more than 1,000 pounds of force. So this only works if the rope is what? It only works if the rope is what? Tight, yeah. The more loose it is, the less force you're going to get. But if it's tight, you can apply a force in the middle of just a few pounds and it'll have the effect of thousands of pounds. You're not going to move the tree, you're going to move the car. And I've moved cars out of ditches, I've moved buildings, I've moved trees that have fallen down or leaned. This is such an easy thing to do. Now I would give you just a little caution note here, is if you are applying a force here and it's very tight, and your pounds are like, 1,000 pounds. These cables can break, and your ropes can break, and that can do some damage to you. So what you could do is get another wimpy rope, and then tie it, and then move away about 50 feet away, and then apply your force of 10 pounds or whatever. It'll have the same effect. It'll still apply those huge forces, but then if it breaks, it's not going to hurt you. So come on, this is something that's super applicable. Everybody can use. All you need is it's called a power winch. They're about $30. They're not that bad. Throw them in your trunk, throw in some rope, or throw in some cable, and you can never be stuck again. It's amazing. All right, go to day 2. God, you know how much AAA costs? Yeah, quite a bit. All right, so take a look at number 1 in day 2. What you're going to do is use your cleverness to solve problems here. It says OA is going to be replaced with vector A, OB is replaced with vector B, and OC is connected with vector C. We want to produce AC. We want to go from A to C using these green, blue, and red vectors. So if I want to go from A to C, which colors should I use? For sure A, and what else? C. Well, A is tricky because we're going to go backwards A, so I'm going to say minus A, and then I'm going to add C. Or you can say C minus A. You use that kind of strategy to go from B to C, and then halfway from A to B. We'll let you figure that out. Cross out 2, we did this one already. We already did those. Number 3, we're just doing a shortcut here, WX, XY. What's WX plus XY equal to? WX plus XY is WY. And what's WY plus YW? What's that? 0. So there you go. This part B is fun. PQ minus SR. So this is the same as PQ. I'm going to put QR next to it because we can change the order. And then instead of minus SR, I'm going to say plus what? RS. See how that works? So PQQR plus RS is the same as P what? PQQR is PR, RS, PRRS is P. Yes, yeah. There's your vector. So you can do that with C and D, prove 5A and B. These are good, 7ABC. Then you're going to find actual lengths with A and B here. And then 15 is the thinker, but it's a great problem. See what you can do with that. And that's day 2 of vectors.